Hello dear students, now today we would move ahead in this first chapter of class 11th chemistry, that is some basic concepts of chemistry. So today we are going to discuss the laws of chemical combination here. Okay, so what are these laws of chemical combination? So before this, let me tell you, as you must be knowing, the elements are combining together to form the compound. Getting it or not? Means we have the elements and these elements are combining together to form the compound. Let's say we have the elements hydrogen and oxygen. Okay, and by combining hydrogen and oxygen we are getting water out of it. So this is the compound. Hydrogen and oxygen both are the elements, and the compound that we are getting is water. Are you getting it? But it is not possible that all the time, if you are taking hydrogen and oxygen in certain amount and you are mixing both hydrogen and oxygen and you are getting water out of it would not be possible all the time. Okay, rather we have to mix the elements. Through chemical means. In a you can say in a fixed ratio by weight and by volume. If you are mixing the the elements in a fixed ratio by weight and by volume, then we are going to get the required compound. Okay, so it is not possible that some amount of hydrogen you are taking and some amount of oxygen you are taking and mixing both and you are getting a water out of it. Okay, it would not be possible. Okay, so rather we would have to go through some chemical means where we have to mix both the elements in a fixed ratio by weight and by their volume. If we are doing so, then we are getting the required compound there. That would be water. Getting it or not? Very good. Okay, so for that purpose we have some laws, and these laws would tell that how the elements are combining to form the compound. Okay, so these laws are known as laws of chemical combination. Getting it or not? Okay, so laws of chemical combination tells how the elements are combining to form the required compound. Getting it or not? Yes. So we are going to discuss now the laws of chemical combination. There are some rules, there are some laws regarding that. So now we would discuss the first law of chemical combination. Are you getting it? Okay. So now we are going to discuss the first law of chemical combination. Okay, so the first law of chemical combination is law of conservation of mass. Okay, so what is this law of conservation of mass? So let me tell you, it means the law of conservation of mass was put forward by Antony Lavoisier. So this was the person who put forward this law. Okay, Antony Lavoisier. So Antony Lavoisier was the person who put forward this law of conservation of mass. Okay, and he is also known as the father of modern chemistry. Remember this. Antony Lavoisier is also known as father of modern chemistry. Okay, now what is this law? What is this law of conservation of mass? So it states that the total mass of all the reactants. Okay, let's say we are combining carbon and oxygen, and out of that we are getting carbon dioxide. So these two are reactant and this one is the product here. Okay, so this law states that the total mass of all the reactants in a chemical reaction, remember this, in a chemical reaction, the total mass of all the reactants would be equals to the total mass of the product. Whatever the product that you are getting, its mass always would be equals to the total mass of all the reactant. Getting it? Getting it? What does this mean? It means neither you can create some mass, some extra mass here, nor you can just lower some mass here. Okay, means whatever the total mass is here should be the total mass here also. So this is the law of conservation of mass. What does this mean? It means that mass can neither be created nor it can be destroyed. Neither you can create some extra mass there. Let's say total mass is here, the mass of carbon is 12 and that of oxygen is how much? 16, and two molecules are there, so 16 to the 32. So total mass would be 44. This is the total mass of carbon and oxygen. And what is the total mass here? That you are getting carbon, that is 12, plus oxygen 16, 16 to the 32. So total again you are getting 44. It means mass of all the reactants, that is 44, is equals to the mass of product. Getting it or not? Very good. It means neither you can create some extra mass. This cannot be 45. Means it would never be 45. And it can never be 43 also. Okay, means neither you can create some extra mass there, or now you can just lower some mass there. Okay, means the mass of all the reactants should always be equals to the mass of the product. Okay, so this is the law of conservation of mass. Getting it or not? Good. So this is the law of conservation of mass. It states that the total mass of reactants is equal to total mass of the product. Yes or not? Good. So it implies what? It implies the mass can neither be created nor it can be destroyed. So this is the law of conservation of mass. Okay, just note it down. Then after we are going to discuss the second law of chemical combination. Okay, just note it down. And now we would discuss the next law of chemical combination, that is law of constant composition, or we also it is known as law of definite proportion. Both are same. And what is this law? So before this, let me tell you. Let's say you have the water, that is H2O, and you are getting the water from the different sources. Yes or not? Let's say first source, it could be tank. Second one, let's say it is pond. And third one, let's say we are getting it from the river. So these three different sources, many other sources are also there. Okay, but I have taken only these three sources. Okay, so let's say we are getting the water from these three sources. Okay, take the water from the tank, take the water from the pond, and take the water from the river. So everywhere you would find that the elements are combined in a fixed ratio by weight and by volume. You would not find that somewhere you have more amount of hydrogen, somewhere you have lesser amount of hydrogen. This you would not find. Okay, always the elements are going to combine in a fixed ratio by weight and by volume. Are you getting it? Let's say we have the water, and by volume, what is the ratio here? Ratio by volume. What is the ratio? We have 2 molecules of hydrogen and 1 molecule of oxygen. So always they would be combining in a ratio of 2:1 by volume. Are you getting that? So by volume, they always going to combine in a ratio of 2:1. So everywhere you would find 2:1. You would not find somewhere 4:1. Never ever. Okay, so everywhere in each source you would find the elements are going to combine in a ratio of 2:1 by volume. And what is the ratio by weight? If you see the ratio by weight here, what is the ratio by weight? Can you tell me this mass of hydrogen? It is 2. 1 it is, so 2 molecules are there, so I would multiply it by 2. So 1 2 is 2, means hydrogen, mass of hydrogen is 1, so 2 molecules are there, I would multiply it by 2. Ratio, what is the mass of this oxygen? It is 16. So if you see, it is 2 1 2 ratio 16, and it would be 1 2 1 2 2 8 16. You can cut, okay, by 2. So you have 1:8. Getting it or not? So always the hydrogen and oxygen are going to combine in a ratio of 1:8 by weight. So everywhere you would have the same ratio of hydrogen and oxygen by weight, and you would have the same ratio of hydrogen and oxygen by volume, 2:1. Okay, so whatever the source may be, what I'm saying, whatever the source of the compound, that is what, H2O. So whatever the source of the compound may be, the elements are going to combine in a fixed ratio by weight and by volume. Everywhere you would find this same condition. Getting it or not? Getting it or not? Very good. Let's take another example. An example of, let's take CO2. Again, we have the different sources of CO2. So let me take here two sources from, we are also exhaling this CO2 in our exhalation process. We are just emitting out CO2. And similarly, the from vehicles also we are getting the CO2. Yes or not? Good. So everywhere you would find the carbon and oxygen are going to combine to form CO2 in a fixed ratio by volume and by weight. What would be the So in both the sources, whether it is whether the carbon that we are just exhaling and whether the carbon that we are getting from the vehicles, so in both of the source of the carbon dioxide, you would have the same ratio of carbon and oxygen. Okay, what is the ratio by volume here? 1:2. So it is the ratio by volume, 1:2. And what would be the ratio by mass? If you see the weight of the mass of carbon is 12, and it is how much is of it is of oxygen? 16, 2 molecules, so 16 to the 32. If you simplify it, you would get how much? 4 3 ja and 4 8 ja. Okay, so by this is the ratio by weight, and this is the ratio by volume. Okay, so everywhere, whatever the source may be of the carbon dioxide, so everywhere you would find that carbon and oxygen are going to combine in a ratio of 1:2 by volume and 3:8 by mass. Are you getting it? So everywhere you would find this same condition. Okay, so what does this law tell? This law tells that whatever the source may be, whatever the source of the compound may be, the elements combine in a fixed ratio by volume and by weight. Getting it or not? Good. So this is the law. This law states that whatever the source of compound may be, the elements are combined in a fixed ratio by weight and by volume. You would have the fixed ratio of carbon dioxide, whether you are getting this carbon dioxide from the exhalation process or whether you are getting the carbon dioxide from the vehicles. So in both the cases, you would have the ratio by volume, that would be how much? 1:2, and ratio by mass or by weight would be 3:8. So similar condition is there for water also. Getting it? Okay, note it down. Okay, then see you in the next lecture where we would be discussing some more laws of chemical combination. Till then, stay tuned and keep watching. Thank you. Have a good day.